All right, class, welcome back to math. We are continuing on learning about tenths and hundredths. And we know these are what we call the fractions with a 10 and a 100 in the denominator. So you should be on page 228 in your instruction book to follow along. And it says at the top, adding tenths and hundredths fractions. So today we're taking it one step further. Instead of just comparing, we're going to add them together. But you guys did really great with adding fractions. So, no anxiety. Okay, we're good. I need a reader to read this problem below, and then we're going to look at different ways that we can think about how to answer it. Noah, go ahead and read about Carmen.
Carmen says that she has 4/10 of a dollar. Troy says that he has 100ths of a dollar. Together, what fraction of a dollar do they have?
Okay, let's mark it up first, okay? Carmen has 4/10 of a dollar. That should be circled, underlined, however you mark it. So if your pencil's not moving, I see you not doing this. Friends at home, make sure you're doing this with us. Troy says he has 50/100ths of a dollar. Together, so if we combine them, what fraction of a dollar do they have? That is our question. I'll put that in the box. What fraction of a dollar do they have? All right, well, let's first look at a picture. We can use a picture to help us add fractions with denominators of 10 and 100. Are our denominators the same?
No.
No, that's why we can't just add the numerators. All right, what does it show that Carmen's got? Look at Carmen's money in your book. What does it show that she has? Noah?
4 dimes.
4 dimes, okay? So I'm going to write that next to this so I don't forget. She's got 4 dimes. If I write, you write. All right, and then Troy, how many dimes does Troy have? Cadence?
5.
5 dimes. So together, Carmen and Troy have 9 dimes. How'd they get 9, Hayden?
By adding this 4 and 5.
Yeah, we added the 4 and the 5. Together they have 9 dimes. 9 dimes is, look at this carefully, 90 over 100 or 9/10 of a dollar. That's just one way to think about it. But it does make sense. If I have 90 out of 100, if I have $1, which is 100 pennies, does 9 dimes equal 90 pennies? Yeah? Let's think about it this way. If I have 10 dimes that make up a dollar, do they have 9 dimes? Yeah. So these are fractions of a whole with pictures. I need to scroll up to show the bottom part that shows a bar diagram. All right. You can use a bar model to help you add fractions and denominators of 10 and 100. Now the hard part with this, I will be honest, when I am doing math, I've never had a time where I've wanted to draw this, right? Is that kind of annoying to draw?
Yes.
Okay, but there is kind of a quick way to do it. So before we even move on, let me show you the quick way. If you need to draw a 100 grid, everyone practice with me in this space. First just draw a square, and then we're going to split it into tenths. So we'll make them columns. So if you kind of try to find the halfway point, then we need 5 on each side. So just do your best. It doesn't have to be perfect. Okay. And I did count my columns to make sure I did have 10. I'll give you just a moment to finish that. So if you have a fraction of tenths, you could very easily draw this. If I had 6/10, then I could go through and shade in 6 of my columns to show 6/10. So that's what they did for Carmen. Carmen had 4/10, so they could make a bar diagram showing tenths and shade in 4. Troy's number, though, was out of a denominator of 100. So if we want to use the same diagram, we have to add another set of bars. Which direction are they going to go? Josiah? Yes, horizontally. So we can do it again. All you got to do is draw 10 lines. So I split it in half in the middle and then do my best to make 5 spaces on each side. So if you ever really do need to draw this diagram, it really would only take you about 20 seconds. Okay? It is kind of frustrating to draw so many lines, but you can do it. So actually, I'm thinking right now, we can do that in about 14 lines. No, 24 lines. Doesn't take that long. All right, now look what they did to find the total money. Since Carmen had 4 columns, did they shade 4 entire columns on this 100 grid? Yes? All right, I got to pause you 1 minute. I have a phone call. All right, back to math. I know something funny just happened. I accidentally ended the video after I had a phone call instead of replay. So you might have 2 math videos to watch. This is the second part. Thank you for bearing with me. All right, we were just talking about how they use these 2 charts to all put them together onto this final one. Okay, so I need more people in here to participate. We know Carmen had 4/10, right? Did they shade 4/10 on this chart?
Yeah.
Yeah, okay. Troy had 50 100ths. Did they shade 50 little squares on this chart?
Yes.
So now, looking at this picture, can we say out of 100 how much of a dollar they have?
Yeah.
How much out of a dollar do they have?
90.
100.
Very nice. You even said it correctly. So they have 90 100ths. Do you think it makes logical sense every time we do a problem like this to draw out these huge diagrams?
No.
Do you guys want to?
No.
Oh, okay. I didn't know. Okay. So would you like to learn an easier way to do it?
Yes.
Okay. Noah, question.
It could also be 9/10.
It could. Very good. So Noah said if I reduce 90 100ths, I could divide the top and bottom both by 10, and I would get 9/10. Good thinking. Okay, so he just simplified it for us. All right, let me scroll up. You all need to turn your heads to the next side of the page. All right, we're going to solve the same problem from the page we just went all the way through, but we're going to do it in an easier way. Let me erase my big chart, all this. Okay. So, hopefully everyone in here answers at least one question, okay? So pay attention. Everyone's got to answer one. Everyone in the back, you hearing me? Okay. What are the denominators of the fractions you are adding? And are they the same? This is not a hard question. So, Abby, are they the same first?
No.
Okay, so we can say, no, they're not the same, and then we'll say what they are. Pencils should be moving.
You could have used a contraction.
I could have.
Where you said they are not.
True, I could have said they're not the same. Nice. I'm going to write that here just so we practice.
Sounds wrong if you say they are.
All right, questions on number 2. That's pretty straightforward. Okay, number 3, stay with me. Make sure your brain keeps soaking this in. We need to complete the equation to use multiplication to find the hundredths equivalent to 4/10. So all we're doing right now is when we want to find an equivalent fraction, and normally we set it up like this, and we have to figure out what that is.
That's 40.
Okay, remember we always have to figure out what did I do in the bottom to change my 10 to 100, and then what will we do to the top? It has to be the same thing. So what will my question mark here end up being? Abby? We have to multiply this numerator by 10. So if I multiply 4 by 10, what would we get? 40. Okay, so remember, if this setup confuses you, which I'll tell you, I don't like when they set it up for me and I fill in the blanks. That's just my preference. Can you always write it to the side the way we've taught you to do it? Mm-hmm. Yep, and then you can kind of look over and see what we need to do. So they're saying 4/10 equals, and then they rewrote 4/10 times something times something. What do we need to put in both of these boxes? Angie?
10 times 10.
Yeah, because that's what we did over here, right? So we can fill them in with 10s, and we got the right answer. So now, if we have a common denominator, can we add up to see how much of a dollar we've got? Sure thing. All right, Hayden, what would I get if I add 40 hundredths plus 50 hundredths? 90 hundredths. Okay, you don't have to say 100. 90 hundredths. Nice job. Questions so far? Okay. So really, we're learning nothing new. It's just kind of combining everything we've done, right? So together, Carmen and Troy have what fraction of a dollar? Noah? 9/10 of a dollar or 91 hundredths. Either would work for me. You can write them both, or you can pick. Both of those fractions represent the same amount of the whole thing, which is $1. All right, now finally, we need to explain how you can use equivalent fractions to add a fraction with a denominator of 100 to a fraction with a denominator of a 10. What's the basic rule of adding fractions? What's the basic rule? What do we have to do? If I want to add, let's just say, one fraction, I've got 1/10. This one, I've got 1/100th. Explain how I can use equivalent fractions to add a fraction with a denominator of 100 with a fraction with a denominator of 10. Hayden?
Never change your denominator.
We can't add when they're different, right? So do we have to change one of our denominators?
Yeah, which is the 10 to make it 100 or 100.
Okay, good. Josiah, do you want to add to that?
And if you basically just have to have one number that is a 10 or one number that with one fraction that has a denominator of 10 or one fraction with a denominator of 100 to change them.
Okay. So however we change, can we change a 10 to 100 or 100 to a 10?
Yeah.
We just have to make sure they are the same. Okay? So that's really all this question needs. If you want to use your own words and really practice, that's fine. You can borrow some of mine, but get your pencils ready. All right. So I'm going to say, when I need to add fractions, the denominators have to be the same.
You put denom.
Yep. So we can multiply the 10 by 10 to get 100. That's one way. Or, Josiah said we could also do it the other way. And I will tell you, even after I write an answer like that, I always need to reread it to make sure it makes sense. So when I need to add fractions, the denominators have to be the same. We all know that. I could multiply the 10 by 10 to get 100 in my denominator. I tried to save you some words there. Or we can divide 100 by 10 to get 10 in the denominator. I will let you finish writing that, and I will scroll up to our try it questions at the bottom. All right, raise your hand if you need more time. All right, I'll give you about 15 more seconds. About there. All right. Well, let's move on down to number 7 and number 8. But I can see on your faces today this is making a bit more sense than yesterday, so I'm glad to hear that. All right, everyone ready to move on to number 7? I've got a few people distracted in my classroom. Make sure we're ready. Number 7. Okay. Giselle is her name. So does someone want to read number 7 about Giselle? Cadence?
Giselle spent 7/10 of her money on a book and 10/100 of her money on food. What fraction of her money did she spend altogether?
All right. First thing, let's mark it up. I'm going to mark it up myself. You do it yourself. You should know how to do this by now. If you want to check with me, that's fine. Do it yourself first. Some of you still aren't doing it. I can see up my eyes in the back of my head, remember? So I get going.
I'm marking the next one.
All right. So I thought that both of our fractions are important because we need to know what she spent altogether. So 7/10 of her money was for a book, and 10/100 of her money was for food. What math operation do we need to do to solve our problem? Josiah?
Basically 10 plus 7.
We need to add, right? However, check our denominators. What's going to cause this problem to be slightly harder? Cadence?
Oh, they're both different.
They're both different. All right. So we get to change one into the other. My style, whenever I like to multiply better than divide. If you would prefer to divide this one and make it a 10, that's fine with me. But I'm not going to do that way. Okay? So let's all take our 7/10, unless you're doing this one on your own. I'm going to write my 7/10 to the side. And I need to make it equivalent to a fraction with 100 in the denominator. So let's start there. Everyone write. Okay, now we know when we're working with tenths and hundredths that we have to multiply by 10. And do we also do the same to the top? Yep, we have to, or the fraction doesn't mean the same thing. So 10 times 10 is 100. 7 times 10 would be 70. Does that make sense?
Yes.
Okay, so now we can add them together. So now my 7/10 is now 70/100. I'm going to put it right here. Plus 10/100 for food equals, all right, now do I add my denominators? Do I put 200 in the bottom? Nope, don't do that. 100 in the bottom, you should have an 80 in the top.
Ding.
Ding, you got it?
Ding.
Thumbs ups?
Ding.
Okay. Nice job. So if I wanted to write a label on that, I could say she spent 80/100 of her money. All right, number 8. I need one more reader to read number 8. Angie, go for it.
The winning car in a race beat the second car by 19/100 of a second. The third car was 4/10 of a second behind the second car. By how much did the first car beat the third car?
Okay. First thing, mark it up. Everyone, pencils, mark it up.
I already did.
Okay. On a problem like this, I've got 3 cars going on. Did anyone else read this and think that's a little bit of a confusing question?
Wait,
Be honest, because I thought it was.
what is this first car?
Okay, thumb up if you think the question's a bit confusing. I do. Okay? So I'm not just going to go for it. I'm going to do my writing off on the side, draw a picture, make a chart, whatever I need to do to understand. So we have 3 cars, right? So I'm just going to put winner, middle, and last. This is going to help me think this through. The winning car in a race beat the second car by 19/100 of a second. So, 1 by 19 hundredths of a second. The third car was 4/10 of a second behind the second car. This is just how I'm trying to make sense of it. Okay, I try to show you all different ways. So I know my winner was 19 100ths ahead of the middle car, and the last car was 4/10 behind the middle car. By how much did the first car beat the third car?
Maybe we need to subtract.
What do you guys think?
We'll make the denomination.
I think I need a picture even. Okay, let's draw a picture. So I'm going to use squares to be cars because I don't feel like being fancy. All right, we've got 3 cars. This is the winner. This one's in the middle, and this one's in last. So the winner, the distance between here and here is 19 100ths of a second. Okay? The distance between here and here is 4/10 of a second. Now I need to know this entire distance. By how much did the first car beat the third car? And I didn't put my question in a box. Did I have to try more than one strategy to figure out my plan?
Yeah.
Yes. Do you think you might have to do the same thing sometimes?
Yes.
Yep. All right. So now, do you guys think we need to add or subtract? Add. What are we going to add to find our total between the two? Cadence?
What does the S stand for?
Seconds. We need to add our 2 fractions. Now, I'm looking to see if I can just straight up add them. Can I straight up add them the way they are?
Nope.
Nope. So let's go ahead and change 4/10 to a fraction with 100 as its denominator. And then we're ready to add.
We already know.
So 4/10, make sure you're writing with me, equals some other fraction with a denominator of 10. Check your work with mine. We should all know this by now. So I got 40 100ths. You got 40 hundredths? Okay. So 40 hundredths plus 19 hundredths. I'll put my work over here. Remember, when we add, our denominators do not change. But, does it say denominator? Yes. Numerators do. So 40 plus 19. Does anyone have a good mental math trick for that? Because I think I've got one if you don't. Hudson?
So really, I obviously don't have to worry about the denominators. So I add 40 plus 19, which is 59.
Okay. When you're thinking about this, you don't need to stack it. If you do, it's okay. But if I think about 40 plus 19 more, my brain kind of just went 40 plus 20, 60, take 1 away, 59. Okay? So don't forget, you can think through mental math. You're allowed to do so. So, by how much did the first car beat the third car? By 59 100ths of a second. Yes.
Once you get the total, why do you have to multiply it by the other number, 1800?
All right. When I got my total number down here, when I changed it to 40 hundredths. Okay. So 40 hundredths, we basically just replaced this number with that so that our denominators matched. And then we could find the total between both of the cars because the denominators matched. Okay? So this problem was hard. It was like a 3-step problem. Okay? But you guys did a nice job. All right, friends at home, thank you for listening today. Do your best on your practice. I will see you soon.